So we're completing that Name That Boundary review to refresh our memory on plate tectonics for our test tomorrow. And when we look at these pictures, each question is going to have a series of 3, and you have to analyze them. Somebody said they see a really deep crack. Does this look on land, or is this underwater for this first image? What do you guys think this looks like? This is actually underwater. Okay, and so when we look at these other 2 images, these yellow squares are highlighting a trench. And all of these trenches, where we see those darkened lines, they're occurring in the ocean. They're occurring in the ocean. So trenches happen underwater, right around, and sometimes right along a coastline. Right here on South America, there's also a trench that's not illustrated here. The Marianas Trench is the deepest place on Earth. In this next diagram, it talks about how Mount Everest could potentially fit inside it, that it is deeper than Mount Everest is tall. And most of it has been, is still undiscovered because they do not have a vehicle that can handle the pressure to go that deep below sea level. So what the questions are asking us is, what type of boundary does a trench occur? What type of crust is the boundary made of? And what kind of land formation is being formed based off of our observations in these images? So to summarize our conclusions, we know that a trench has to happen at a convergent boundary. And what happens at a convergent boundary is the denser oceanic plate is subducting or sinking below the continental plate, which creates that trench. The trench happens right near that subduction zone where those plates would have met if the oceanic plate didn't sink. That sinking causes that big, deep depression in the ocean floor. It's almost as if you could follow the trench, follow the oceanic plate down into that trench, into the mantle. And we also determined that this happens at both oceanic and oceanic collisions and an oceanic plate and a continental collision. Okay, so for the next one, we have 2 images of different mountain ranges. One is the Appalachian Mountain and one is the Himalayan Mountains. And I think the easiest question to answer first is, what kind of mountains are these? And then we can determine the boundary and the crust type. So we determined that these are folded mountains. The Himalayan Mountains are the best example that we have discussed all unit. And they're formed because 2 pieces of land, 2 continents collided. And that's going to be your Indian plate and your Eurasian plate. And they collide and fold up. Okay, so we have a convergent continental collision, and that makes folded mountains. Our third example is, we have a scuba diver really deep underwater looking at a bunch of rocks. We have a diagram where magma is coming up through a divide and oceanic crust is being pushed outward. And then we have a map with really long red lines being identified. So based off these observations, I see that we have a divergent boundary here because the oceanic crust arrows are pointing away from each other. And everything is underwater. So this says oceanic crust, oceanic crust. This is all underwater. And all of our red lines, minus this one random one here, are in the ocean. So I'm going to say this is oceanic, oceanic. And what landform is formed at a diverging oceanic boundary? So when you have ocean crust splitting apart, going in opposite directions, you get an ocean ridge. And if you look at this image, it's like an underwater valley, almost. It's underwater and you have these big rocky pieces where that new rock is building up and building up and building up. This is also where seafloor spreading occurs. So that magma comes up, and when it reaches the ocean surface, like in this scuba diver picture, it cools and hardens into rock. And as the oceanic crust divides, that rock is pushed and pushed and pushed further away from the ridge. But the ridge is created because that's where new rock, where magma is hardened into new rock. Our fourth example, we have a mountain, but it's got a big hole with like a mini mountain inside of it and some smoke coming out of it. We have a map that's illustrating red triangles. That most likely symbolizes volcanoes. And then we have an illustration that's showing an oceanic plate. And I know that it's oceanic because I see the water, and this plate's under the water, and it's being pushed down below the continental plate that has a volcano on top of it. So this diagram is illustrating subduction, where that oceanic crust is being recycled and melted back down into magma. So the type of boundary, because these arrows are moving toward each other, tells me that this is converging. I can see ocean in this diagram, and I can see land. So that tells me it is oceanic and continental. And when oceanic and continental collide, and that oceanic crust is recycled down, it turns into magma and makes volcanoes, which explains the other two illustration. So we get volcanic mountains along the coast. Okay, this is the coast right here where land meets water. We're going to have a whole bunch of volcanoes right here. Our fifth image, it says name the process. So we're not naming a landform, we're naming a process. And in each one of these diagrams, I see arrows pointing toward each other, and I see volcanoes, and I can see the trench in two of them. So we're right here where my mouse is, where that space between the two colliding plates, that is where your trench would be. And each one of these diagrams has a volcano. So we know it's a converging. But what process is happening here? It's a process. So let's look at that. What process? Is this seafloor spreading, folded mountains, volcanic mountains, or subduction? Subduction is where that denser oceanic plate is pushed down underneath the less dense plate, and it's melted down back into magma to feed that volcano. So this is subduction. And what kind of crust does this occur at? We're having converging boundary. If we look at our diagrams, this first one, I have land and I have water. The second one, I have land and I have water. But this third one, minus that random volcano, it's all water. So I am assuming that this can occur at both oceanic and oceanic continental crust. Our sixth image, we have a map of Iceland. This will be on your exam. And it shows that the North American plate and the Eurasian plate are dividing. And then the other two images, I see a deep valley, a really deep valley with two plateau type cliffs on each side. So what land formation being created? That's the easiest to answer. Is it folded mountains, a rift valley, a ridge, or a trench? We have a deep valley, and these two arrows are pulling apart from each other. Okay, so these arrows tell us that the boundaries are moving away, they're dividing, which is a divergent boundary. And if we look at our images, all I see is land, land and land, land and land. So this is telling me that land is dividing, so our crust is continental, continental. And this always makes a rift valley. If it looks like a big valley on land, then Rift Valley will be your answer. Our seventh boundary, we have really big cracks in the ground, something we might see as a side effect of an earthquake. It's not quite as deep as a valley, and it's on land, so it can't be a ridge or a trench. So this looks like something, an earthquake caused this crack or scrape in the ground. And if we look at this image of the San Andreas Fault, we can see an arrow, two arrows that are running parallel to each other. They're going side by side. So when you have two plates that slide side by side, it is a transform boundary. And by the looks of this image and this map, everything that is happening 100% on land. So in this particular area, we are talking about continental, and the landform that's being created. It's not as deep as a trench or a ridge. It's very shallow. It's almost like a cut on the ground where like you maybe scraped your knee. So I'm going to say this is a fault. And the most famous one is the San Andreas Fault. So a fault happens at a transform boundary, and the one in California, San Andreas, is the example you need to think of. You can always think about the movie San Andreas and that being about a major earthquake to help you remember that this is a transform boundary. Our last diagrams show us several volcanoes. I see a lot of volcanoes here. I see a big volcano here. It's also talking about the Ring of Fire, which is the ring of volcanoes around the Pacific Ocean. And this top image, we got a few pieces of land, and then we have some islands right here. This looks like the Aleutian Islands in Alaska. The Aleutian Islands were an example we used to describe a convergent oceanic boundary. So when we think about what forms volcanic islands and the Ring of Fire, we know it has to be some kind of converging boundary because subduction is what's responsible for these volcanoes. And the type of crust, if we look, it's all ocean. And if you look at these Aleutian Islands, it's all ocean. So we're going to say oceanic, and your land formation are volcanic islands. Okay, so I would practice this a couple of times to help prepare for your exam tomorrow.